everyone, welcome back to my YouTube channel and to the start of another new project. So 10 years ago I done this compressor up mechanically, so anything it needed it got, from piston rings to bearings to reed valves, non-return valves, V-belts, gaskets and so on. At the same time I also enhanced the look and the quality of the entire unit by powder coating all of its components. I also made up a device to tumble the vessel with an abrasive media that I had made up laying to clean the inside face of the tank. At that time it was only a year old, but me being me, it had to be done to remove any corrosion or to prevent any corrosion from reoccurring in the future. So around 3 years ago on my YouTube channel, very near the start of my channel, I put together a small video of that process using old outdated video clips that I had stored on an old Samsung S3 phone. Since then it has done a lot of work. Honestly, it has been abused because of the large volumes of air I pull from it on different occasions. For example, when using my sandblaster, the pumps couldn't keep up. They couldn't hack the pace. Because of this, a year ago I decided it's time to upgrade, or it's time to revamp this tandem compressor. I'm only getting around to it now, so I have killed two birds with one stone, as it's something different, unique, making it an interesting project yet again. So I have decided to make a push to do this project build now, as it's essential for all the pneumatic tools and the systems I require for all my future projects. That being the new upcoming Aqua Blaster build, but also it's hugely required for my sandblaster, my powder coating booth and paint spraying of new projects. More specifically, it's required for the project models that I'm currently creating, the Smart Glove device and the e-bike build, but also it's required for this new Aqua Blaster that I'm building. So this Aqua Blaster is required for another project, a project car. So all these projects are interlinked. It's much like a family tree of projects. So I'm really stuck without this compressor at the moment. So I have decided to increase the volume of air that is pumped into the vessel by adding two new industrial grade high flow rate two-stage pumps. I will also need two new motors capable of driving them. Other components will need to be upgraded too for the pumps to fill the large 270 litre vessel in the desired time. For example, the non-return valves, the check valves at the back of the compressor need to be replaced to a higher flow rate. The tandem compressor currently weighs 215 kilograms, so it's quite heavy, just below a quarter of a ton. It has two single-phase 2.2 kilowatt motors and two 14 CFM pumps attached to it, giving it a large air displacement for a piston compressor at 28 CFM. So the biggest of its kind in single phase. However, I'm going bigger. When I'm finished with it, it will have two new 4 kilowatt motors and two new 25 CFM two-stage pumps, giving it a much larger air displacement at 50 CFM plus. So you can't buy a tandem single phase compressor that I seek or that you will see here, but you could purchase a very expensive screw compressor. But where's the fun in that? I should point out before I go any further here, I am not 2 foot tall. The compressor currently sits 5 foot off the ground to this galvanized frame. I might not put the compressor back up here again. I haven't made my mind up yet, as it will be much beefier and it will be much taller and it will be much heavier, weighing over probably 280 kilograms when I'm complete. So the headroom might not be available, and I also don't want to drop this frame. So when I place the two-stage pump on this base here, this platform, the head of the pump might hit the roof. So I'm going to start this project off by stripping all of its components to reduce the weight to aid me to lower it to the ground using an engine hoist or an engine crane. Oh, and yes, I still have the tumbler, the device I made for tumbling the vessel. So let's put it to use for the second time in 10 years. So I'm going to do it again because obviously the video quality, the video format will be much more enhanced than 10 years ago. So I hope you enjoy. So I'm going to start stripping the compressor here now. Okay, so to start this project off, I'm going to now remove both pumps, both motors, the guards, the V-belt, all the components that are not required anymore for this compressor. So also the copper pipes here leading to the check valves at the back of the vessel. So I will do this now, but first I should point out this vessel will still weigh probably about 160, 170 kilograms. So I must use an engine crane to get it down. So I will start here now by removing the guards first. So there's the back panel and there's the cover for the panel. That's one off. Okay, so that's the two guards off. So I won't be using these guards again. So I will be making my own, probably out of stainless or something like that. So the next step now is these copper pipes. Seen here, if I can get out of the way. So the copper pipes feeding the vessel, there's two of them obviously because this is a tandem. So there's the first one we don't need. Second one, I'll just take this down. So the next step now is releasing the tension on the belts by slackening the motor, or both motors, shall I say. Okay, so I already have a belt off this one because I've noticed wear on the pulley and the belt, so I forgot that that was taken off a while back. So we'll start with this motor now. Okay, so there's one motor, not required. Okay, so the next item that I will remove is this pump on this side. Okay, one pump removed. Next item is this next motor. One belt that won't be used again. Another motor, so second motor. Okay, so the final item that needs removed is this fire pump. The back's sore now, so I'm going to have to sit down here. Okay, so here's the final pump. The second pump removed. So there's some heat up at that roof. I won't be using these pumps again as mentioned. The pumps that I will be using will be two-stage. They will be much bigger than this one. So my next step now is removing all the cables and taking it from there and lowering it to the ground. Okay, so the next step is removing both cables for the two motors and also the cable for the pressure switch. So these cables are run to this fancy panel here to the left of me, this control panel. Okay, so the final stages here is removing this outlet pipe, this drain valve, which is like an automated valve for draining the compressor off any moisture or water in the tank, the vessel. This tank currently sits at an angle towards this valve at this end. I think it's a couple of degrees just. Then we will remove the two non-return valves. So I'm also going to remove this pressure switch, as the diaphragm was messing about on it the last time I used it. I have previously repaired it, but for all the price of the pressure switch, I'm just going to replace it. The pipework going to the pressure switch from the non-return valves also will be removed. When that's done, we will lower this vessel to the ground finally. So here we go. I'll start off with this outlet, this pipe. Okay, so here's that valve. I've got the solenoid and the timer removed. So basically that drained the compressor off every 45 minutes. So it's quite a cool mechanism. Okay, here's one non-return valve. So I will not be using this again. So here is the second non-return valve. So the reason I will not be using these again is because one end is 1/2 inch and the other is 3/4 for the vessel. So the pumps that I've got now, if I was to use this valve, this would restrict the flow of air into the vessel. So I need 3/4 by 3/4. I have already purchased them. They're quite expensive. So I'll set these in the ground too. Next thing is the pipework. So this is required to provide the pressure to the pressure switch from the vessel. That will be required again for the new non-return valves and this new switch that I'm going to get. So final steps, removing this switch. There we go. So that's us. We're going to drop this to the ground now. So what do you see if I can lift it here? It's quite heavy. So we've still got a blow-off valve here. So a safety valve, and we've got the feet and this ball valve. Yeah, so we'll drop this to the ground now. Okay, so that's her stripped. So before we move on here to lowering this vessel to the ground, I just want to demonstrate or show the components, the parts that came off the vessel there. So here we have everything on the ground. So I'm not going to throw all these components or these items out, but what I might do is these pumps, if anybody wants them that knows me, they can have them. The same goes for these two motors. Here's other reed banks or the valves for the pumps that I removed after a year. I don't know why I did. I just did it because I'm off my rockers. But there's two valve banks there. We have all the gaskets that's also there for those two pumps. So if you look at those pumps, you can see that the oil is nice and clear. So that's telling you that they weren't overheated. That's the same oil that's been on them pumps for I don't know how long, probably 5 years. So that shows you that even though that I abused the pumps for sandblasting, they are still okay to use. So moving on now to lowering this vessel. Okay, so I'll try and get much of this in view as possible. Oh, she's going sideways. So I'm using my foot here at the engine hoist ram. So that's enough, as long as it doesn't hit the wall. So bringing it back, nice and easy. Okay, so I need to watch the camera stand here. Yeah. Start lowering it down here now. So it's going down gently here. Had to make this extension for the engine hoist because the compressor overhang that much. Need to make sure it doesn't fall out here when it's going down. So I'm just going to set this on the floor. Then we're going to put it on the tumbler again. For the second time in 10 years. Okay, so hoping that doesn't slide out. Might be alright. Because the pressure's on it. Okay, there we go, safely down. Okay everyone, so it's been 2 weeks since I started this project. So 2 weeks since I disassembled the compressor, since I lowered it to the ground also. It hasn't moved since then. So I've been extremely busy with, well, a lot of 3D printing. So printing components or parts that make up my smart glove. So it's a very tiring process. The vapors in the air, the toxic level of the resin in the atmosphere. So it leaves you very tired. It's very sore in the skin, it's very sore in the eyes. So if I look a little funny today, that's the reason why. So today I am following on with this project by tumbling the vessel. So what I mean by tumbling the vessel is that I will be placing this vessel or this tank onto my tumbler with my media inside it to clean the inside face of the tank or the vessel. So I have to, it's quite time consuming, so I have to let it run for approximately around 4 days on its flat. Then I will let it run for another 2 or 3 days at a 30-degree angle to clean these faces. So the dome faces at the side of the vessel. Hopefully that makes sense. So 30 degrees that way, 30 degrees that way, and 4 days on its flat. So quite an interesting video. So the first thing I have to do here is remove this large 2-inch bung on the side of the vessel. This is quite a tricky process because these bungs are really tight. The threads are tapered NPT threads, and also the last time I stripped this compressor, what do I see here? I used this hydraulic lock to seal the threads, or to seal that bung. So that bung is an inspection bung. When I remove the inspection bung, I will use this camera, this bore scope camera, to inspect the inside of the vessel. I also will use this torch that I have made up, tape the torch to a fiberglass rod to insert into the bung so everyone can see exactly why I'm tumbling the vessel. So when the bung's out and I've inspected the tank, I'm going to make up my own media, which is, what do we see? These drywall screws. So I have selected these screws over the gold zinc one because they are much sharper at the tip. The threads are also nice and sharp, so they will rotate inside the vessel and score the face of the tank, removing any rust or any grime. So I have 4 boxes of those, and I also have shattered glass. But that's not the only shattered glass I have. I have another couple of panes to break up outside. So they are actually, well, it's actually a coffee table tempered glass, so it's quite strong. When that's complete and the media is inside the vessel, I will take the vessel to the garden. Well, I will insert the media into the vessel on the garden so I don't mark the powder coated finish here, because it will be on its side. Then I will attach my tumbler. I will push the tumbler up on its end or on its feet. Then I will start the process. But other tasks need to be complete, such as adding balancing weights at the opposite end of these channels. So if you can imagine, these channels are 2mm, 3mm thick. So I will attach weights at this end using roof laths soaked in water. So I'm going to slacken this bung now and take it from there. Hopefully everyone enjoys. Okay, so I have the compressor set on skids, which are made specifically for slackening this bung. So I have 1/2" Milwaukee guns and 1/2" snap-on guns, but they will not remove this bung under no circumstances. So what I'm going to do here now is I'm going to attach this 3/4 drive socket, but I also need to use this 2" tube as leverage. So I should point out, I already have this bung cracked. So my girlfriend, she has held this end of the compressor with her weight. She's not heavy, I'm not trying to say she's heavy, but she just a wee helping hand at this end. The skids are 6 foot long. It was quite tight, so I have basically just used a blowtorch to heat the inside of the bung, so the heat doesn't disperse into this nice powder coated finish on the vessel. So I'm going to slacken this now. I will set the camera up and then we will move straight on to inspecting the inside face of the vessel. So I'm just demonstrating here what I have done to crack this bung. It might still be very tight because, as I say, I just cracked it one night. I had time. So I have previously tried to slacken this bung when the compressor was sitting on the ground, but it was very, well, it was useless without these skids. So these skids are there so I can add a lot of torque when I'm pushing on that tube against the wrench. So what I have done here is just heated it until this blue part of the vessel started to get, well, hot, but not too hot in order to melt the powder coat. Okay, that's enough. So the heat will obviously interfere with the bond between the inspection bung and the vessel. There you go, so you can see there how tight this is. So as I say, a 3/4 inch impact gun, and definitely not a 1/2 inch gun, would not shift this. Well, if you put heat on it, it might with the 3/4 gun. So 10 years ago I replaced this bung because somebody destroyed the other one with an adjustable spanner, and me being me, it needed to be changed. So you can actually see the hydraulic sealers on it still, and the cord that I used then. Okay, so there we go. So if you can imagine, this bung was new 10 years ago. So you can see all the rust, the water droplets, the moisture that clung to this bung. So the tank's obviously going to be the same, maybe not as bad, because I coated the tank with a wax before, or 10 years ago. I could still feel the wax, so the wax is still there. Grime. So that's it. We're going to do a little test now with the inspection camera. So I'll keep the camera rolling here. So this will be my first time looking at the vessel. So I'll put on the torch first. Without it falling in. So what do you see if you can see there now? Let's shine the torch in. Okay, so it doesn't look too bad. You can still see the wax on the vessel. But I'm going to tumble it anyway for this video. So I'm going to place the camera in and look at the inside face here. So what do you see if I can get this first in a nice position? So there we go. It's very hard to make out here. So if you look at it there, you can see the rust, the buildup of rust on the face. But it's not that bad. And the reason it's not that bad is because I have maintained the tank back then. But if I look closely here, you can see the little rust spots. So what I'm going to do here now is I'm going to make up my media, and I'm going to place it into the vessel. So I'm going to have a little look here a little further and see if I can see any more contaminated spots, and then I will record it. So it looks good and clean in there. You can still see the wax on it, but I'll find a bad bit here. Okay, so just a little final video clip here on this. So if you look at the bottom of the vessel near where the dome part is welded to this roll part, you can see a little discoloration. So this is obviously a rust buildup. If I look and move the camera about here, you can see a little pitted areas too. So I should point out, these pitted areas are not as big as they look. The camera is only picking up approximately about a 5mm radius. So you can see the little rust areas. There's not that much. I'm actually quite shocked. But I'm going to continue the process here, the tumbling process anyway. So as I say, I'm shocked at the condition of the tank. I wasn't expecting it to look so well. The compressor's been used for 10 years since I done it up, since I tumbled the vessel, and since I applied that wax oil to the inside face. So that's just proof how the wax oil works. So that wax oil is the wax oil that's used for car shells or car bodies. I forget the make. I'm not sure if it's not sure now. Is it Granville or Granville? But yeah, it's really good stuff. So here, if I get the torch again, I'm gonna take this scoop out of the tank. So there's the size of the camera. It's quite small. So that's the reason it'll be picking up little porous areas. So looking at this bung, you can see the rust, the buildup of rust on the inside of it. So this bung was replaced the time I done the vessel up, as I say, because somebody chewed the nut at this side of the flange. So there's big gouges in it. So the tank did look like this. So I'll get the torch again. So 10 years ago, the tank looked like this and then on the inside. And that's the reason I tumbled it. But for this video, I'm going to continue on here and tumble it anyway outside now. So I'm going to make up a media. I'm going to put the media in the tank and then I'm going to continue this tumbling process. So hopefully it all goes well. A lot of work, not really required. But for this video, I'm just going to do it now anyway. Wax oil is incredible stuff. Okay, so I am sitting in between the two uprights of the tumbler. So we have a motor and the bearing at the side. So we have a flange bearing at the side and we have a flange bearing at the side. So this is the media that I will be using as I discussed. So this is tempered glass, so it's quite strong. I don't know if I'm going to use the chipwood screws now, the drywall screws, because the tank's in, well, good condition. So here we go. We're going to break this for media and this for media, and then we'll gather it all up. I'm thinking about also putting liquid in the tank first to clean the wax oil before I insert the media. Otherwise the media will stick to the inside face. So here we go. Okay. This is funny. Wasn't expecting the glass to go everywhere. But it can be swept up, even though I'm situated on top of a pile of stones. How awkward. I probably won't need all of this. Oh. Okay, so I am back in the garage here. I forgot to complete a very important task, and that task is reaming this hole out. So it would be very stupid of me to ream this hole out once I have the vessel tumbled and cleaned, because the metal filings would fall into the tank. So I'm going to do this now and then I will follow on with the tumbling process. But first, I just want to give a little discussion of why I need to do this. So here we have the two old non-return valves, 1 and 2. Beside them, we have these other two new ones, which are all 3/4 fittings. So this is a 3/4 thread, and this is also a 3/4 thread. But the hole in this valve is much smaller. It doesn't require a big hole or a big high flow rate because the pumps were smaller. But now that I'm using larger pumps, I need these larger non-return valves. So if I was to attach this non-return valve, I'll put this torch down for a minute, to this point. So if I was to screw this into here, the air coming from the pump would enter the vessel at this point and into the tank itself, or into the vessel. So basically the air's coming through here, this port, but the problem is it will hit this face of the tank, this inner skin. So I need to match this size of the hole to this non-return valve. So basically, if I keep it the way it is at the minute, it would restrict the pump outlet. So basically it would reduce the flow of air from the air pump and into the tank. So the pump would work harder, it would run harder and more likely feel quicker. So what I need to do here now is ream this out to approximately 16 mil, the same size as this hole, or a wee bit bigger. So this will not weaken the tank, because if you look at this closely, the weld is at the other side of this female fitting, this boss. So I should point out, these valves is approximately 50% bigger, the hole diameter, This hole is around 10 mil, these two, and these two are around 16 mil. So it's just over 50% bigger. So this will allow the flow of air to the tank to be much greater without interfering with the pumps. So I'm going to do this now and then we will move on to tumbling. So I'll ream this now using this Dremel, this electric Dremel tool that I have here with this carbide burr. So I'll place the camera on the stand and continue on. Okay, so if you look in there at that hole, let's see if I get the torch. You can see there at the minute it is around 10 mil in diameter. So I'm going to take that out now to approximately maybe 16 to 18 mil. I'm going to move the camera back out of the way because this little tool I have here is quite long. So she's a Hitachi, she's German, and the model is a GP3V electric die grinder, you should call it. But it's not obviously not a Dremel, it's much bigger. So it has a 6 mil shank, and hopefully I have it tight. We have a carbide burr in it, and we're ready to rock. So here we go. I would have put my earplug in before I go any further. If I can find one. There it is there. Okay, there we go. So we're out to about maybe 14.5 mil. So I'm only going to do this one. I'm not going to do the one over here, this side. Just for to speed this process up, this video. So I'll continue on here and I'll take this out to 16 and I'll stop and continue the other one off camera. Okay, there we go. Okay, there we go. So one complete. So I'll get the torch here again. So you can see there now the hole's much bigger. So I'll finish this process off. I will ream this other hole, then we'll take the vessel outside to start the tumbling process. Good job. Okay, so I finally have the vessel out in the garden. I have the tumbler sitting here behind it. I will talk about that in a moment. But first, I just want to give a little brief discussion on what I'm going to do before I add the media to the tank, or to the vessel, to the inside of the vessel. So, I have this drum of kerosene oil, which will be poured into the vessel, along with a few screws, a few hundred screws, shall I say. So, I have 4 boxes. I'm going to insert probably 2 of those boxes along with the oil to break down the wax on the inside of the vessel. So in doing this, I need to bung up the ports. So I'm going to use the accessories taken off the vessel, the accessories that I won't be using again. So basically I will be screwing these into each one of the ports on the vessel. So that being the inlet ports, the outlet ports, and these large bungs, or these large portholes here at the side of the vessel. So when I go to mount this vessel to my tumbler, I will be using the big flange nuts at this point and at the other end of the vessel seen here. So I need to remove this 3/4 bung, leaving this 2-inch bung in place on the side. Okay, so this is the freewheeling side, the left hand side of the vessel. When you're looking directly at the Shamal label, the logo, this is the left hand side. So I'm going to start off here by removing this 3/4 inch bung. So I have made up this special adapter. So it's a 28mm shaft welded to a hex nipple. So this hex nipple is actually cut in half and weld it directly here, seen at this point. Then the shaft is placed into the bearing. So I'm going to mount this now just to demonstrate how this is done. So that's it. So this is the freewheeling side. This side will be mounted directly to my tumbler at one of the uprights. So moving now on to the driving side here. Okay, so at the right hand side of the tumbler we have this driving mechanism. So we have a wiper motor, we have the 2-inch large flange nut, we have the special adapter also at this side, which is 3/4 to 28mm. So this special adapter sits snugly inside this bearing. So at the rear end of this carrier, this bearing, we have a shaft that directly connects the wiper motor to the adapter. So when the wiper motor turns this shaft, it turns the special adapter that's connected to this large flange nut. And in turn, it turns the vessel with the special little carrier bearing on the left hand side of the tumbler also. So I'm going to demonstrate here now inserting the media. So when I say media, it's going to be liquid and screws to break down the wax first. Then I will move on to the glass after the inside of the vessel is cleaned. So I will do that now. Then I will attach the tumbler to the vessel. I will demonstrate how to do this. But first, let's do a little demonstration here of this mechanism running. So if I plug in this power supply, 230 volts AC in, DC out, so 14.4 volts out. So it's a 12 volt power supply, but I have adjusted up the wee potentiometer to 14.4 volts to give me a higher speed here on this DC motor. So if I was to place this DC power onto this terminal here, we can see the wiper motor turning the shaft, which turns my special adapter, which turns this large 2-inch flange nut, which will be directly screwed into the vessel. We also have this higher speed here. There we go. So I've changed the speed, this wire, over to the opposite terminal here. So this is running at approximately 14.4 volts. So that would be required because when I insert the media into the vessel, it will create a drag and slow everything down. So I'm going to now start this process off by inserting the liquid and the screws into the vessel. Then we will attach this tumbler to the vessel itself. I nearly forgot, I need to attach these bungs first. Well, they're acting as bungs, these accessories. So this is a drain valve. So these two inlet ports that I have reamed out also need to be blocked. So I am using these old non-return valves. You can see that I have attached PTFE cord. So here we go. One blocked. Two blocked. Okay, so the final port needing blocked is this port for the pressure valve. We also need to place this gauge on to keep the oil or the media from protruding out through this hole. So that will do about there. So hopefully this doesn't hit the bottom of the tumbler. If it does, I will bung it with some sort of a nut instead. So I have a new one of these for this project, so this won't be used again. So that will do. Moving on now to the media. So starting off with these dry lining screws. There we go. Moving on to the oil. So remember, this is only to clean the wax off the tank. So about a gallon of oil. That'll do. before I make a mess. Okay, we're ready for the tumbler. Okay, so I've decided to go with the same amount of kerosene again. So in total, 2 gallon into the vessel. Need to make sure not to get this on the grass or we will kill it more than likely. So I've went with 2 gallon because the vessel is quite long, as it's a 270 litre. So it's a big brute. Well done. So let's get this thing on the tumbler. Okay, so it's important that I tighten up this special adapter before I mount the entire tumbler itself. So there we go. Okay, so rather than make my life difficult, I'm going to bring the tumbler up towards the vessel. Rather than trying to place the vessel on the tumbler because the vessel is very heavy. Especially with the media inside now too. So here we go. Making sure not to scratch the vessel, of course. So once this big 2-inch nut is in position, I can start tightening it into the vessel. There we go. So I'll bring the camera down nice and close here. Okay, so I'm going to start tightening this nut with this large shifter to make sure it is on the right threads. Okay, so there we go. Now I can use the motor to finish this off, this tightening process. So like so. So you can see here this gap is tightening in. Need to make sure not to go too far. There we go. Tighten the rest with the shifter. Okay, so that's that side done. Moving on now to the left hand side, the freewheeling side. Okay, so this is the final stage of attaching the vessel to the tumbler. So I'm going to use these 2 bolts now to directly connect this carrier bearing, or this bearing housing, to this upright. Okay, that's it. So back up to its feet now, the tumbler, which will pull the vessel up. Okay, before we pull the tumbler over onto its feet, I just want to give a little discussion here about these mount points. So if you look at this nut, you can see that it has a pile of gouges in it, a pile of marks. So the nut for the compressor is removed and this old one is used. So as you can see, I have 4 of them here. At this side of the vessel, we have the original nut, the one that's currently being used on the vessel. So I don't have to go near this with a socket to slacken it. So as you can see, I have removed this 3/4 bung as demonstrated. So just in case anybody's wondering where this gold 2-inch nut came from. So that's one that won't be used again. That's only for the tumbler. Another thing I want to point out here, if you look at this valve at the bottom of the tank, this blow-off valve, here at this point, I was worried about this hitting the tumbler. There's about 4-inch clearance here, so it will not hit this frame. So that's good. So we're ready to rock here. So when I turn this tumbler on, I need to watch that these bits sticking out, that I don't get hit by them on the arm or on the leg. Because they will be coming round at quite a force, especially with the weight of the media inside the vessel. So here we go, I will lift this off now and turn it on. Okay, so this is going to be very difficult. I already tried standing here and pulling these, but I don't want to break my back. So I have these skids in the ground to keep this frame from digging into the grass at both ends. I'm going to try and lift this up here at this point. It's going to be difficult. I'm not going to lie. So up on its feet first. Okay, so that's not going to work. I don't remember how I done this the last time, to be honest. I don't remember. Just like that, maybe. I do put myself through some torture, but it's worth it. So hopefully you can see that nice and clear now. I'll bring it into view. So hopefully there's no oil or kerosene leaking on the grass. If there is, I will maybe move the entire vessel on the tumbler to the concrete. But that's okay, there's no leaks. So I will turn this on now. Make sure it's not going to hit first. So you can hear the screws and the fluid. You can see that the compressor's heavy, top heavy at these two plates. The mount points, the mounting locations for the pumps and the motors. So I'm now going to add weights to these feet. Basically just lafts, wood lafts or lafts of timber, whatever you call them, soaked in water. So they've already been soaked in water, they've been lying outside. So I'll do this now. Okay, so before I start this process and let the vessel tumble for probably about a couple of hours just to clean the wax off the inside of the vessel, I just want to demonstrate here what I'm talking about, the unbalanced motion. So here we go. So you can see the way the tank's going. Like my noises. So you can see when these plates, these channels get to the side, there's a big change in momentum or in the motion. So we want this more balanced. So I'm going to add weights at this side where the feet are to make this more balanced. So basically 180 degrees away from these. So at the minute we have an unbalanced motion. So I'll do that now. So if you see here, the heaviest part of the vessel falls to the bottom. We want that to be sort of equal, maybe stopping there or thereabouts. So that's just not the weight of the media. So if I put that here, you can see how it falls back around. So I'll add weights here now using these wood lafts. So basically what I'm going to do is have maybe 3 or 4 at this side and 3 or 4 at this side across these feet. Like so. So we'll screw these on now. Hopefully this makes sense. Okay, so as you can see, this one's protruding out to the opposite side of this upright. So I need to cut that and put a few more screws in this. So you can already see how it's hanging that way with those battens on, or placed or screwed on. So this screw is going down through the feet, or the foot, into these lower lafts. Okay, so we'll cut these and maybe add on more weights, more lafts, but we will try this first. Okay, so I should point out, the reason I want this balanced is to, well, so there's less drag on the motor, so it doesn't destroy the wee gearbox too, also at the other end of the motor, seen here. There we go. So we'll try this, and well, I'm going to add more screws first, but hopefully it works. There we go. I like it already. You can see how it's more balanced, so it's easier to push. No? Still falling the opposite direction, but what I'm going to do is add more laughs here. Okay, so just to demonstrate that I have not compensated for the weight difference at this time, well, you can see there it starts up much better. So they're helping. They're definitely working there, you can see. There's no less whoa, whoa, whoa. So I'm just going to run this wash, this kerosene wash, using these wood rafts, but when I add the heavy media, the glass, to the vessel, I'm going to need to increase the weights at the feet. The next thing I need to do now to make sure the screws is not running to one side is level the vessel. So I'll get a level here now. Okay, so it needs to come up 5mm at this side. So I'm going to use these little wedges to raise the tumbler that little bit. So not very much. So this is just to get the media balanced inside the vessel. So that's near enough there now. So I'll take the camera off here and just demonstrate what I'm doing. Okay, so if you look at the bubble there in the spirit level, you can see that it is center, it is level. The vessel is level. So we don't want the media going to one side, otherwise one side of the vessel will be cleaned and the other won't. Once we go to wash these two dome faces, I will lift the tumbler at approximately about 6 inches to 12 inches at one side. So I'll run this now. Oh, forgot to take a level off. It's lying in the grass, it's okay. So there we go. I will let this run now for probably about 2 hours and just clean the face. It's probably cleaned already, to be honest, but better watch it don't get hit here when I go to get this spirit level. So that's a sample of or demonstration of the tumbler in working mode. So that tumbler's been lying up for 10 years. So this is the first time it's been used since. I also have these heavy weights, these barbell weights to add to the vessel. So I'll basically screw those to the laughs when I add the heavy media that will score the tank on the inside. So that's it. We'll let this run for 2 hours, then we'll drain it and we will sample the liquid, and then we will add the media, the rough media, the glass, the solid media. So there we go. So you can see how wonky this is, but it still works. Okay, so to clean this dome part off the tank, what I need to do is lift the tumbler up. I'm going to turn it off a minute so I don't wreck the place. So basically lift it up like so. So obviously I'm going to be cleaning that end now. I could go higher. That'll be okay, I think. Okay, so now we're cleaning the, what is it? The right hand side of the tank. So basically all the screws and all the kerosene is now lying at this end. Seen here. So if I move the camera around a wee bit. So all the screws, the chipwood screws and the kerosene is now cleaning this face. What I'm going to do is I'm going to finish this off, and then we're going to insert the glass seen here. So I'm going to do this off camera. Because I've already explained everything. So I'm going to clean the left hand side of the tank off camera. Then I will remove this 2-inch bung again, insert the glass, but first I need to drain all the kerosene out of the tank. Okay, so just a little demonstration here of lifting this a little higher to clean more coverage or more percentage off this dome. So the more vertical I get the tank, the better for cleaning at this point, but obviously at that side. So one more block, and that's as high as I'm going. So if you can imagine now, if I bring the camera over here, if you can imagine now the slope here, the screws are hitting a big percentage of this dome housing, or this dome end of the vessel. So I'm going to do the left hand side now, then I will demonstrate removing the liquid. We'll sample it, then we will insert this media for the final stage. So the vessel is now lifted on the right hand side, so this cleans the left hand side of the vessel. So as you can see, the angle is approximately 30 degrees off the ground. So I'm now going to drain the tank, then we're going to insert this media for the final stage. Okay, so I forgot to do a wee video clip there of the tumbler going at maximum speed. So the power supply is set at its highest voltage, the motor is set at its highest setting. So there's no resistive circuit between the power supply and the motor. So if you listen carefully, you can hear the kerosene and the screws working together to break down the wax on the inside face of the tank. So I'm going to drain the tank here now. We'll sample the liquid, see if there's much wax in it. Hopefully there is. Then we will insert this media, this glass. Okay, so I have a wee slight angle, a wee slope to this end of the tank. Oh, look at the colour of it. So this was obviously clear when it went in. It's coming out brown. Obviously we're going to leave the screws in there for now. So obviously that brown stuff is the wax and other bits of dirt. So there's 2 gallon on here, so I need to make sure this doesn't overfill. Get another drum here. So when this drains, or when it is drained, I'm going to remove the tumbler, take the 2-inch bung off the right hand side of the vessel and fill it with the glass, the shards. So this toughened glass. So there we go. So placing this bung back in. Well, valve, I'm using it as a bung. There we go. Okay, so as you can see, the cleaning was a success. So look at the colour of this drum, and it was immaculate before I placed it under the vessel. It was blue. So obviously this brown residue is the wax. So, good job. Okay, so again we need to start this process off. So I need to remove the compressor from the tumbler in order to get access to this 2-inch bung on the driving mechanism. So here we go. So that will do. So the final stage here is removing this big access nut. So this will be the port where I place the glass into. just like the screws and the kerosene. So I'm going to use the motor here to slacken this, if it works. There we go. Just to save any screwing. There we go. So now I need to move the tumbler out of the way and insert this glass media. Okay, so I'm going to insert maybe half of this box. I'm not going to insert all of it. So here we go. So keep in mind, there's 2 boxes of screws in here too, which will provide better scoring to the inside face of the tank. Well, the both of them will work together. Okay, so I have about half a box of this glass, this broken glass inside the vessel. So you can hear I have it stacked up here to the bung. Obviously it's going to be on a slope. It's not going to be the whole way across yet until I tumble it. What I'm going to do is I'm going to stop putting glass in there now, and I'm going to insert 2 more boxes of these dry lining screws, which are very sharp. So the glass will break down. Hopefully it doesn't break down too quick. The last time I used a different type of media. So the last time I used, well, sandblasting grit. I think it was glass media. Wasn't as coarse as this. I also used screws, the same type of screws, and I left a nice finish in the inside of the vessel. So I'll put these 2 boxes in. So that's 4 boxes of screws, £6 each, £24 cost for the screws. Obviously they're going to be done, they're going to be worn down in the end up. So the screws is more or less in there for backup, because the glass will likely turn to dust in a week or so, or maybe 3 days into it. So this will be my final time tumbling this vessel, just to point out. So I'm going all in here. You're probably wondering how I get the media back out again. Well, I have to put the compressor up on its end and basically work everything out with your 2 fingers. It's not that bad, to be honest. Much the same as this. Only you've got gravity working with you rather than against you. Obviously the tank needs to be placed up on its end. So we're nearly there. Nearly ready to connect the tumbler back up again. And you will hear a big difference this time. Hopefully it's not too heavy. So that's it. I need to make sure there's nothing on the grass here, otherwise when I go to cut the grass for the lawnmower, there'll be a bit of a handle to watch the eyes. So that's it. 2 final screws. I'm going to attach the tumbler here now and then turn her on. So all's well. Okay, so the final clip here of this tumbling process. So as you can see, the tumbler is rotating much slower than it was previously. It's at its lowest setting, and the reason it's at its lowest setting is because it provides more torque, the motor does. So it's quite a heavy load inside of there now. You can hear it going up the walls. So until this media breaks down into smaller pieces. So I'll give a wee example here. We'll not talk about the water at the minute. So if you can imagine this rotating here now clockwise, the media is going up the wall, up here because of the large chunks. So you can sort of see it there, or hear it inside doing this. So it's doing it because of the large pieces of glass. So there's pieces of glass I put on there maybe 3 inches long by 2 inches wide. So until this media starts breaking down, the tumbler will become more effective, if that makes sense. Because of the extra load that's on the vessel now, the motor started to heat up. When the motor starts to heat up, the motor becomes less effective. So that's why I have the hose here trickling water over the rear end of the motor, but the motor's nice and cold. So obviously it's safe working voltage, it's only 12 volts DC, well 14.4. Well, it's running smaller than that at the minute because it's at a slow setting. But that's it. So I'll let this run now on its flat for approximately maybe 3 days. I'll turn it off at night time and I will turn it on tomorrow morning again about 8 o'clock and basically just let it run until it cleans the inside base of the vessel. So that's it, everyone. Quite interesting. The tumbler's actually really effective. As is the water. The water cooler. So the water, we're not wasting water, it's only a wee dribble. Okay, I am on day 4 of this tumbling process. So I have the flat of the vessel complete. I'm now working on the right hand side of the vessel. So I have a chair placed under the tumbler to give us this nice angle, this 30-degree angle. So this will take 1 day to do this end. Then when this end's complete, I will move on to this end by placing the chair at the right hand side of the tumbler. So this tumbler, the vessel, as you can see, is speeded up from the earlier video clips. This is because, well, 2 reasons. There's additional weights attached to the lafts to remove that oscillating motion. So it's a much more balanced system now. Also, the power supply itself was not screwed up to its maximum setting. So I thought it was, but it wasn't. So as I say, I will complete this process now at this end for the next day. Then tomorrow I will switch the chair to the opposite end of the tumbler to move the angle or to move the media to the opposite side. Okay, moving on to refresh everyone's mind, and with the tumbler now locked at this position for this final demonstration, here's what the compressor looked like with the smaller pumps and the motors attached. Okay, so I'm just going to run through some dimensions of this old assembly. So the height of the motors are 250mm. The height of the pumps are 340mm. The depth of the motors are 290mm. The depth of the pumps are around the same, 290mm. So now moving on to the new assembly. So here's what the compressor will look like when this custom unique upgrade is complete. Okay, so as you can see, the compressor is now much more beefier and chunkier. So I'm going to take a few dimensions here of the pumps and the motor, the entire assembly here. So the height of the motors are 320mm. The height of the pumps are 420mm. The depths of the pumps are 350mm. And the depths of the motor are 440mm or thereabouts. So they're huge. So I'm going to do a wee walk around here now on this entire assembly. Okay, so I will finish off the mounting and the wiring and the plumbing of these new electrical and mechanical machines when the time comes. So when the tumbling is finally complete, I will start mounting these motors and pumps, is what I'm trying to say. So I also need to make new guards for the rear end of the compressor seen here. So I will do those when the time comes, probably the end of part 2 of this entire project that will appear in my channel in hopefully 2 months time. So ignore the grease on the pumps. I'm just using this to reduce the corrosion until I complete the project. Okay, so the motors I selected are 2800 RPM. The pumps require to be driven at 1400 RPM. So that's for optimum performance. So I had to select these pulleys for the motor. So I've done a few calculations. I will get into that in part 2 also on how I selected this pulley so that this pump still runs at 1400 RPM, optimum performance. Okay, in part 2 I will also have to feed a copper pipe on both pumps, seen here, this port at this cooler, after cooler, to this port on the vessel and this port seen over here. We will also need to attach these 2 new normal return valves as discussed earlier in this video, so that they match the pump, of course. Okay everyone, so that's it. I hope you enjoyed this video. Please hit the thumbs up if you did. It has been a long process, mainly delays because of the poor weather, but also getting someone to help me to lift this vessel to the garden for this tumbling procedure was not easy. As mentioned throughout, the results of the tumbling process will follow in the new part video soon on my channel. If you want to see this project or this beast evolve, please subscribe and hit the post notifications bell to see all the latest from my channel. Also, other interesting projects will follow soon, such as my one-of-a-kind 100 miles per hour e-bike, my unique mechanical iris, my aperture, and my unique smart glove. So thank you everyone for watching, and haters, envious and jealous, bite me.